All right, welcome, ladies and gentlemen, to week 16 Open Q&A. My name is Brian McLogan, and I am here to answer your questions. So if this is your first time you're joining me, welcome to Open Q&A. Basically, I have questions submitted to me on my community post as well as on Discord, and I will go ahead and answer them to the best of my ability. If you do have some questions that you would like me to answer, feel free to go ahead and submit them on Discord, or every Saturday, I always make a community post where you can respond to your questions there. A lot of people, and I know this is just kind of how YouTube has it, they submit some questions to like last week's post. So just always remember that, whenever I make a post on Saturday, that's going to be for the upcoming stream. Sometimes YouTube will still like show you the post from last week. So that's why I was actually going through that other post to be able to see if there's any other additional questions that I could kind of cover. But the questions that I actually pulled from are from my Discord. And if you have not joined the Discord, then you can go ahead and click on the link in this description and go ahead and get signed up. It's free, guys. I have basically different broken up. I have everything broken up into different classes as well as for my open Q&A. So therefore, if you just have some questions that you would like to kind of see how other people could maybe help you solve or whatever else, then just go and post in whatever your class, and then people will respond. There's been plenty of people that I've seen helping other people solve their problems, explain what they needed to do, see where they're getting stuck. And then obviously there's some problems that I'm able to reply to and help people out in time. But yeah, the main idea of everything was for me to be able to create an additional community where you guys could get some help. And I know there's a lot of other websites and availability for you guys to get help, but I just wanted to give it something else to try that you guys could go ahead and post your questions to. There's also the open Q&A section of the Discord where therefore I kind of look for questions to be able to address. So if you just have a question you'd like me to address on the live stream, you can go and post it in the open Q&A, and that's where I grab these questions. So let's go and take a look at what I have in this case up here. So the first one is, if f is continuous at x equals 2, then find the possibilities for a. So we have a nice little piecewise function, basically finding the values a that makes the function continuous. We're going to work on graphing a rational function. We're going to look into solving the solutions for this equation, cosine of theta minus sine of theta equals 1 on the interval 0 to 2 pi. And then we're going to look into graphing 2 cosine of 3x minus 2 pi. Now, again, if you've solved, I've done a lot of problems like this. So I'm probably not going to go through, I might just do maybe one initial period. But as far as graphing, that's not something I really spend a lot of time in my own classes anymore. So I will find at least all the important parts that I ask my students to do. And I'll kind of give you exactly what I would expect for you to be able to know and do for the graph. And then we'll kind of see how graphing goes. But it's always kind of sloppy, especially if you don't have like the graph paper, and depends on like how direct you're trying to be on there. But I will kind of cover that. And then I did see some additional questions coming through here that I'm going to add. So this one was, and actually I just like got a thing. So this one was actually sent to me on Instagram, and then I told them to go ahead and post it on the community post, which they did. So, minus px. Oh, geez. I got to go and factor that. Okay. All right. That's one I'd have to go and work through. I remember doing those. I just don't recall going through. I'll have to work out through that. Kamisha, if you're on the live stream, go ahead and post it on Discord, and I'll go and get you on your questions. I didn't really read all the way through. I know those. It's just been a while since I did work through those, so I want to make sure that I can get that addressed for you. And then, all right, I'll do this conic section one. That sounds finally ellipse. So let's see here. We have a center of -1, -4, and a minor axis of length 4, and a vertex of -1, -7. Okay, yep. So that will be enough information for that. And I think that was everybody else that posted on that last post. So yeah, everything else should be good. So cool. All right. So let's go ahead and take a look at you guys. Thank you so much for joining in. Addie, Wendigo, Samir, Aussie, Mick, Fatico, long big name, Ronnie, good to see you, Drift, Ms. Benjamin, good to see you guys, Seth, Kiana, thank you so much, guys, for joining in. I appreciate you guys checking in, and hopefully that this can be a beneficial live stream for you guys. These five questions probably should take me up to the time limit for at least my live stream for tonight. But just want to let you guys know that, again, this is getting into week 5 of at least the distance learning in my class. So if you do have some other questions in addition to mathematics, but also just some other kind of questions you'd like to check into my stream, will also be going live on a Wednesday of this week, where I've been doing, since we've been doing the distance learning, I have been kind of picking a topic to kind of talk about on distance learning from a teacher, a student, a parent kind of perspective, and just kind of there to kind of do a little bit of math, but not really as the main focus. So if that's something is joining you, or you have some other questions that are not directly like math problem related, feel free to join in on that live stream, and that will be on Wednesday at 9 p.m. as well. All right, so ladies and gentlemen, let's go ahead and get into... Uh-oh, you're not getting better internet, Benjamin? Well, thank you for letting me know about that. Let me check my audio stream. Low latency. Well, thank you, Benjamin. I'm just going to check this out. Oh. I might have figured it out. Check with me, see if that is... Sorry about that. Yes, and Addie has it exactly right, where you guys can just go ahead and type that in. So, Benjamin, sorry about that. Stream run fine, as Benjamin said. Okay, I will go ahead and move on. But yeah, I did check my internet level, and I was doing fairly well before. But sometimes the my Ethernet cord, though, doesn't have the little clip at the end, so sometimes it does get loose. So that's why I was kind of wanted to check with that. But everything else seems to me. I did check the internet before, so it looks like everything is good from on there. So, all right, I will. All right, so let's go ahead and move on to the continuity. So the first problem here, guys, is determine if f is continuous at x equals 2. Find the possible values for a. All right, so we have a function, piecewise function, and basically we have these 3 kind of functions connected together, and we don't know the value of a. And that's what we want to do, is find the value of a that is going to make the function continuous. So if it makes the function continuous, that means we're basically connecting them, right? And there's really, to kind of not like spend so much time on this problem, at 2, like the graph can either be connected or disconnected, right? There could be a hole, an asymptote, like there's all these different things that can happen at 2. But they're saying the graph is connected, right? So what that means is that these two, like whatever the graph looks like, or like let's say at 2, right? So here's one graph, and then the other graph has to fit it, like fit right into it, right? So they're going to be connected. So at 2, when x is equal to 2, the y value is exactly the same. So what I'm going to do is I'm going to create an equation here. So I'm going to say like ax squared. So again, like you could write these all as y equals ax squared, y equals a plus a, y equals 1/4 ax squared plus 3, right? And like x is the input, y would be the output. But if the output is exactly the same when x is equal to 2, then we can say, all right, we want the 2 outputs to be exactly the same when x is equal to 2. And that's an a and a 9, which I know look very the same. So therefore I have a 4a. Oops, what happened to my equal sign? Okay, so we have a 4a equals to an a plus 9, and then you could go ahead and solve for a, and that equals 3. Okay, 6a. All right, so an a equals 3, that works. But again, it says find all the possible values. Well, could there maybe be some additional possible values? And I'm not sure if I copied down exactly everything right from their problem, but I just wanted to kind of see, well, what about this other, what about the other value here, right? So that's when x was greater than 2 and x equals 2. This is when x is going to be less than 2. So at x equals 2, that means it's going to be 12. Okay, so now let's go ahead and connect these two. Well, actually, it doesn't really make sense. I'm just going to kind of go through at least what they would have done. Plus 3 through a plus 9. So what if you went ahead and connected these two, right? Because technically you have a graph. Well, it says, oh, whatever that value is at 2. So you basically have 2 points. You have a function to the left, a function to the right, and then a function in the middle. Now, actually, technically, I think when I originally read this, I was like, oh, you can see how this would work, but let me just go and continue the problem, and then I will try to make sense of it, at least for how I'm getting at this answer. So what if you would have chosen these other two problems? Like if, let's say we wanted to connect these two when x equals 2. So you do the exact same work. So I'm just going to do a little bit extra work because I could explain it from here. But I just want to kind of show you here. This is going to be a plus 3. Ah, shoot, that's a squared, wasn't it? Ah, did I not write that in there? Sorry, that was a squared. So that's a squared plus 3 equals a plus 9. And therefore, you could say a squared, get everything set equal to each other, minus 9, subtract 6, minus a minus 6 equals 0. And therefore, you could factor that down into an a minus 3 times a plus 2 equals 0. So here's the point that I'm trying to make. A lot of times when we have a system or when we're trying to find continuity, you could have 3 different functions, or you can have obviously more. So you could check that continuity between both of those, or between from the left and from the right. However, I want you to understand this is the way that this function works is you have this function to the left of 2. This is the value at 2. And then this is the function to the right of 2. So you really don't need to do it twice. However, let's just say the reason why I'm doing it twice is because what if you chose these 2 functions first, or these 2 equations first, rather than these 2 equations? Well, if you would have chosen these 2 equations to find the value a, you would have came up with 2 different answers. Now, obviously, it doesn't make sense for 2 different answers to be the value that makes the function continuous. There's only going to be one value that's going to make the function continuous for these 2 functions. And that's why if you'd have your 3 answers, which would be a equals 3 and a equals -2. So therefore, using these 2 you can see that's going to give us when a is equal to 3, which is going to be actually our solution. That's going to be our value that's going to work. And then again, you can see that the value that they do connect at is 3 plus 9, which would be 12. So hopefully that works. That was a little bit more of a roundabout answer than I wanted to probably use, and I apologize for that. But basically the important thing here is, and I also forgot to be the a squared. When you're trying to find, when you know there's a squared, there's going to be always 2 cases for that, right? There's going to be 2 solutions. Whereas this case, you know that there's only going to be 1 solution. So I think it really kind of comes into understanding what this graph potentially is going to look like and knowing that there can only really be 1 value that's going to make the function continuous. Okay. All right. So let's go and get into the next one, which is graphing. Now, rational functions, I don't spend a lot of time graphing with my students either. We used to, and it just took so much time when graphing technology is so much easier and better and faster. However, we do spend a lot of time with my students, simplifying, basically factoring the numerator and denominator and identifying the x and the y intercepts, as well as identifying the asymptotes and holes. So that's what I'm going to do. And then kind of show you what I used to expect my students to be able to do to be able to come up with the graph. So the first thing we're going to do is simplify. So by simplifying here, I can factor out a -3x in the numerator. And that's going to give me a x minus plus 4. The denominator here, you can factor that into an x plus 4 times a x plus 1. All right. So now you can see that my x plus 4s divide out. That means those are going to create a removable discontinuity, which will be a whole. So there, anyways, we have a negative 3x over x plus 1. All right. So from there, we need to talk about our discontinuities, right? Discontinuities are the value that's going to make the denominator equal to 0. So going back to our original problem, it's easier to look at the factored form. We know that when x equals negative 4, that made the denominator 0. Before I simplified and factored things out, when x equaled negative 4, that made the denominator 0. When x equaled negative 1, that also made the denominator equal to 0. So those are your two discontinuities. Now, negative 4 makes the factor x plus 4 0. Well, that gets divided out. That means it's a removable. That means it's a whole. It'd just be like an empty point on the graph. So I'd say x equals negative 4 is a whole. And then if I wanted to figure out what x plus 1 is going to be, that's going to be a non-removable, right? That doesn't get divided out. So we can say at x equals negative 1 is going to be a vertical asymptote. All right, so we have our whole and we have our vertical asymptote, and then we have our simplified equation here. The next thing I would do is identify the x and the y intercepts. Now, I'm going to use y and x because it's a little bit easier to do it that way. So negative 3x over x plus 1. All right, so just remember the y-intercept is when x is equal to 0. So I'd basically just plug 0 in for x. And you can see that I would get the... what the heck am I getting? The y-intercept is when x is equal to 0. Yeah, so therefore, y equals 0. So y is equal to 0. The x-intercept is when y is equal to 0. And looks like that's going to be also when x is equal to 0. Because you plug 0 in for y, you'd multiply that on the both sides. So you'd have 0 equals negative 3x, and then divide by negative 3, and x would equal 0. So my x and my y intercepts both occur at 0, 0. The last thing I can identify is my horizontal asymptote. And remember the horizontal asymptote, we're going to use the horizontal asymptote test, basically a comparison of the exponents. And when the exponents are the same, either in the factored form, simplified form, or the original form, since they're both 2, we know that the horizontal asymptote is going to be y equals leading coefficient over leading coefficient. So I can say my horizontal asymptote is going to be y equals negative 3. Okay, the only other thing you could do is go ahead and plot the whole at negative 4, like figure out what that would be. So if you wanted to kind of identify that, you could just plug in negative 4 into the simplified version. It doesn't look like it's going to be a nice number, so I'm just going to leave that. Well, let's go ahead and figure out. Let's just figure out where this whole would be. So if I was to plug in a negative 3 times negative 4, divided by negative 4 plus 1. Oh, actually, no, it does work out good. So therefore, that's going to be a positive 12 over negative 3, which equals negative 4. So at negative 4, negative 4. All right, so let's go ahead and plot our graph here. Okay, so at negative 4, we have a whole. 1, 2, 3, 4. 1, 2, 3, 4. Okay, at negative 1, we have a vertical asymptote. All right, and then at negative 3, we have a horizontal asymptote at y equals negative 3, I'm sorry. 1, 2, 3. Okay, and then we also know that we have our x and our y-intercept is at 0, 0. Okay, so now I've just got to identify what is the graph. Now, I can just tell you from my understanding and knowledge of reciprocal and rational functions, I can see that I'm going to have a graph. Even though this is a whole, like there's going to be parts to the equation on to the left and to the right. So I know that the rest of the graph has to be in this quadrant, and therefore the other graph has to be in that quadrant. So I'm not going to graph anything in these two quadrants because obviously it's a function, right? It has to pass the vertical line test. So just through like my understanding through them, and again, I could be wrong, but I would have placed a pretty good bet that the graph is going to look something like this. Nice little hyperbola. and then go in there. Now, if you're not sure, what I used to tell my students, and I'm not going to go through this for the live stream, but a couple things that I used to have my students be able to do is pick points on the table for to the left and to the right of every asymptote and hole, and then plug them in and see what their value was. But either way, I think you would have done that. You will see that you would arrive at some kind of graph and decimal from there. But technically, I would just rely on graphing technology. But you should know how to identify the asymptotes, the hole, and the x and the y intercepts. All right, question number 3. Cosine of theta minus sine of theta equals 1. We're going to solve, which again, in this one, you could also go ahead and use graphing technology to like verify your solutions. And that's kind of important too, because a lot of students have trouble like understanding when we have extraneous solutions, why that makes sense. And sometimes using the graphing portion is going to be something that is very helpful to be able to do. So in this problem, what I looked at is, a couple things is using really identities to solve this one. And I can't really, I didn't try that. Plus 2 sine cosine theta. Yeah, that didn't really work out. So a couple things you could do is we know the Pythagorean identities. Basically mean we know sine and cosine are related for the Pythagorean identities. Now, the problem is, if I square things, that's not going to give me, if I square the left and the right, I can't really do anything else that's really going to help me solve. Like you could add certain terms of both sides or multiply by certain terms of both sides. But either way, no matter what you do, it's not really going to end up on something that makes it a simplified kind of version. However, I do kind of recognize if I square both sides, I'm going to get cosine squared and sine squared. And that makes me think of my Pythagorean identities. So I don't want to just square both sides though, because if I do that, I'm going to have my middle term. It doesn't seem like it's going to work. That's going to be a -2 sine of theta cosine of theta. So one thing that you could maybe do is let's go ahead and put the sine of theta to the other side. So therefore I'd have a cosine of theta equals 1 plus a sine. Geez, I don't know why I can't think. All right, now I have this cosine isolated. And now I'm going to square both sides. Now, be careful when you square both sides, you're now taking basically a linear equation for your variable. And now you're squaring it. You're introducing a second set of operation or of solutions here, basically like a quadratic equation. You're going from a linear to a quadratic. Remember, a linear equation has one solution. Quadratic has 2, right? So we got to be careful. We got to look for extraneous solutions whenever we are squaring both sides to solve. So I have cosine squared over here. And then here, I'm going to expand this as 1 plus 2 sine of theta plus sine squared. Now, we might be in trouble here if you're looking at this because you're like, all right, well, if I'm going to get them to the same side, it's going to be sine squared of theta minus sine squared of theta. So I'm going to use identities to rewrite this as 1 minus sine squared of theta. Now everything is in terms of sine squared. And that's important. That's very, very important because when I'm trying to solve, unless you're using like the zero product property, like most problems, it's necessary or at least helpful to be able to have everything in the same trigonometric terms. So now what I'll do is I'll just add a sine of theta, or sine squared of theta, and I will subtract a 1 on both sides. All right, so now I get 0 equals 2 sine of theta plus a 2 sine squared of theta. All right. So now you can just factor out 0 equals 2 sine of theta. That's going to be 1 plus sine of theta. All right. So now I can apply the zero product property. And by applying the zero product property, I get the sine of theta is equal to 0 and the sine of theta is equal to -1. Now, we're supposed to go and solve on the unit circle on the interval from 0 to 2 pi, right? So first thing we can do is we can look at the unit circle and say, all right, actually, Yeah, actually, I made this up, so I'm not sure how their answer is supposed to be written, but I'm going to solve it from 0 to 2 pi. So if I need to solve on the interval 0 to 2 pi, I say when is sine of theta equal to 0? Well, sine of theta is equal to 0 at 0 and pi, right? Here and here. That's when the sine of y is equal to 0. And then for the sine of theta equals -1, that's going to be at 3 pi over 2. Okay, so we have these two answers, and then we have this one answer right here. Okay, now, or maybe they had all solutions, I don't remember. But again, we have to make sure we squared both sides, right? So we're going to want to make sure we check for extraneous solutions. So what that means is we're going to want to plug in these answers into this equation to make sure they work. So let's do cosine of 0 minus the sine of 0 equals 1. That should work. So the cosine of 0, oops, I'm sorry. Those are not thetas. Those should be zeros. So the cosine of 0 is 1 minus the sine of 0, which is 0, equals 1. So 1 equals 1. That one works. Now let's do pi. The cosine of pi minus the sine of pi equals 1. Well, the cosine of pi is -1. The sine of pi is going to be 0 equals 1. -1 does not equal 1. So pi is not a solution. And then last but not least, let's do 3 pi. So cosine of 3 pi over 2 minus the sine of 3 pi over 2 equals 1. Cosine of 3 pi over 2 is going to be 0 minus a -1, which equals 1. And therefore, you can see that that one works. So my only two solutions is going to be 0 and 3 pi over 2. There you go. So, and again, since you only have those two solutions, you could add 2 pi n infinitely to those two problems from there. That wrong with divide and cosine. Yeah, you're not going to want to divide by your function of cosine from there. Well, I don't know. I'd have to go and look back at the problem, or at least what point you're looking at. All right, so for question number 4, now we're just going to look into graphing. And again, guys, I'll kind of give you at least the points in this system and setup that I'd use for graphing, but without probably doing too much of actual graphing. So the first important thing that you need to know for cosine, you just need to know what the graph looks like. Okay, I'm just going to do 1 period. I'm not going to do 2 periods, but you should know the general idea of the graph for cosine. Looks like that. It goes up to 1, goes down to -1, completes a period at 2 pi, has a minimum at pi, and that graph is pretty bad. That's going to be at pi halves. That graph is at 3 pi halves. Okay, so that's the parent function, or what we call the initial period. That is something you should be able to have or know. Remember that for cosine, it's going to be y equals a times cosine of b times x minus c plus d. Okay, now notice that is going to be our transformation form. When we want to identify or we want to graph it, we want to make sure it's in that form. So if you notice, our equation, or the equation that I was provided, is not in that format. 3 has not been factored out, right? X needs to have a coefficient of 1. So what I'm going to do is I'm going to rewrite this. I'm going to factor out a 3. Now, 3 cannot be factored out of 2 pi. So but again, think about what happens if you could factor out. Like, what if it was a 6? Like, 3 factor out of 6 is 2, right? So what are you doing? You're dividing out the 3. So since I can't actually divide out a 3 from 2 pi, I can just rewrite it as -2 pi over 3. And again, like, check my work. 3 times x is 3x. 3 times a -2 pi over 3 is just going to be a -2 pi. All right? So what this tells us is A represents our amplitude. That's basically how high and low the graph is going. So the amplitude is going to be the absolute value of A, which in this case is the absolute value of 2, which is 2. Okay, so the graph is going to go up to 2 and down to 2. The period is going to be how long the graph takes to repeat itself, which is 2 pi divided by b. B, which has been factored out, is in this case 3. So that's going to be 2 pi over 3. The phase shift is going to be if the graph is shifting left or right. And you can see that now that I've factored out the 3, You can see the phase shift, you just see, right? Now you can see the graph is being shifted 2 pi over 3 to the right. It's not 2 pi to the right, it's 2 pi over 3 to the right. So my phase shift is going to be 2 pi over 3 to the right. And then the vertical translation is going to be shifting up or down. And you can see the graph is not being shifted up or down at all. So therefore, that's just going to be none. Okay. Now, the only other thing that I would have if I was actually going to be graphing this would be identifying the X scale. So the X scale is how often something important happens in the graph, right? And you can see here, we start at our max, then we go to an intercept, a minimum, and an intercept, and then to the max. So you can see this broken up into 4 different parts. So if I take my period, so the X scale is basically the period divided by 4. So if you took 2 pi divided by 3 and divided it by 4, which is the same thing as multiplying by 1/4, you would have 2 pi over 12, which is pi over 6. Okay, so basically that means every kind of tick mark is going to be at pi over 6. Now, the interesting thing with this problem is it's starting, instead of the graph starting or having that initial period at 0, the initial period is now 2 pi over 3 to the right. So therefore, that's why it's not fun to go and graph. Like, here's the graph. Let's just say it's going to start, let's say here's 0, right? So now it's going to start at 2 pi over 3, right? So the next tick mark is going to be pi over 6 over, right? Because that's the X scale. That's how far the tick marks are between each other, is pi over 6. So a lot of times it's just easier for us to be able to write this as 4 pi over 6. Therefore, you can see the next one is 5 pi over 6. Then this one would be 6 pi over 6. And then this one would be 7 pi over 6. And now, instead of going up to 1 and down to 1, it's going up 2 and down 2. So the graph is going to look something like this. Wait a minute. Boom, boom, boom. Oh, I still got one more to go. 8 pi over 6. So there, there, and there. So yeah, so the graph would look something like that. Not trying to be perfect. And obviously you'd want a simple like 6 pi over 6. You could just write that as pi, right? You could just write 8 pi over 6 as, what is it? 4 pi over 3. Let me actually just fix that out. Just write that a little bit smaller. But that's why I just don't spend a lot of time with the graphing portion. I think you should know the amplitude, the period, the phase shift, the vertical translation. You should know how to rewrite it. But the graphing portion, I just usually refer to a lot with my students just to be able to do it because we would take so much time practicing graphing. And besides like basic problems, you know what I'm saying? We didn't really need to get into more details. And obviously, guys, you can continue that graph, right? That's just the initial period. Typically, when I used to do this, we used to have like 2 or 3 periods we had to graph. All right, let's go ahead and wrap this up on question number 5. So question number 5 is, I believe they're asking for writing the equation. So we're given the center, the minor axis length 4, and the vertex. So remember, the center is always in your terms hk. The minor axis length is going to be 2b. And the vertex is going to be a point. But the important thing about the vertex is the distance from the center to your vertex is a. So the first thing we're going to want to do is plot all of our information. So we have a center, -1, 4, 1, 2, 3, 4. Okay. We have a vertex, -1, -7. So 4, 5, 6, 7. Okay. So if that's my center and that's my vertex, let's just count the distance, right? 1, 2, 3. So I can say A is equal to 3. The distance from the center to your vertex is A. All right. Now that's very important in our equation. Also, we recognize that the center and the vertex both lie on what we call our major axis. And that major axis is going to be vertical. So we have a vertical major axis. This is very important. Since we have a vertical major axis, we're going to use this equation. X minus h, quantity squared, all over a squared, plus y minus k, quantity squared over b squared, is equal to 1. All right, so we have a squared. We know the minor axis length is 4, so therefore 2b, because the minor axis length is from covertice to covertice, so therefore we can say b is equal to 2. So we have a, we have b, and we have hk. So now all I got to do is do x minus a negative 1, all this all over 3 squared, plus a y minus a negative 3, y squared over 2 squared equals 1. And now we just go and simplify. So that's going to be x plus 1 quantity squared over 9 plus y plus 3 quantity squared over 4 equals 1. And there you go, ladies and gentlemen. That is writing the equation of the hyperbola. Oh, Samir, that boy Leo, please teach logarithms. I know what I'm doing. Oh, there was another problem I was going to get to on the rules of exponents. Ah, crap. Forgot about that. I did remember this is another thing that was on Discord. And the only thing I just wanted to kind of mention is the student was saying, like, how do I remember like these rules of exponents? So the best way I like to remember the rules of exponents is like using just what am I doing? Oh, just using like variables. So yeah, like if you have x times x over x, right? So that's technically x squared over x to the first power, right? Which we know is x going to be 2 minus 1, which is x. Because technically x divided by x is just going to leave us with x, right? So you can use like that simplifying rule to really understand things. And again, I can switch this around. Like if I was going to do x over x times x, then that's going to be x to the first minus 2, which equals x to the negative first, right? Because those go ahead and divide out, which is the same thing as 1 over x, which is one of those things we kind of talked about. Like when you have x to the negative first power, that's going to be equivalent to 1 over x to the first power. And you could do this for the power rule, the quotient rule, the power to product, all those kind of rules. I would just use multiples of x. So that is just one thing I wanted to kind of get to. I was going to talk a little bit more about those, but all those rules, I would just use x to kind of base everything off of. Oh man, can you help me find solve the product of squares of 2 consecutive integers? Oh man. All right, guys. Well, I hope you enjoyed the stream. Again, I will be live on Wednesday night. And again, guys, if you do have questions, thank you so much for joining in my live stream tonight. If you guys do have questions, make sure you guys go to Discord and submit your questions, or wait for me to post on my community post in YouTube, and I will get your questions there and see what I can do for the live stream. Hope you guys have a great night and a great week for distance learning. I will see you guys next week or on Wednesday. Have a great one. Cheers. Well, let's see if that works. Yeah.